look at each individual expression, first thing you want to do always is look to do what? Remove any common factors if you can. All right, so that's always the first step. Then you look to see, does it fit any special factor forms? And then you move to the rules for reverse foiling and so on. Okay. Now, the fact that this coefficient, so it doesn't fit any of the patterns, but this first coefficient, this leading coefficient, is a prime number. And anytime you have a prime number, then it's possible for trial and error to be more efficient. And so I'm going to talk through this in trial and error first, and then I'm going to rewrite the middle term. And since 5 is prime, what that tells you is there's only two possibilities, 5x and x. Okay? Again, only one combination that will give you 5x squared for your product of the first terms. And so you know that has to be the case. Now, -6 has relatively few factors, right? It's either 1 times 6 and 2 times 3. Okay? So again, you really only have to at most test a couple different variations on this. So this one, as far as trial and error goes, is set up to do that with relative ease. Okay, now, when you look at these, if you want to determine what numbers to test here, you see that your product is negative. What that means is one sign is positive and the other sign is negative. Most likely, which side will the negative be on? You know, the way that I've drawn my factors, the left or the right? Since the overall sum of the outer and inner terms is negative, most likely the negative sign is going to be on the right. Why is that? Why do you think that might be true? Right? Perfect. When you take your outer compared to your inner products here, 5 times some negative is the most likely case of getting your overall value to be negative. Now, it's not always going to be the case, okay? But again, it's a good place to start, and the whole point of trial and error is if it's efficient, use it. If not, rewrite the middle term. Okay, so when we look at this, so we only really need to test 6 and 1, 3 and 2. Now, if neither of those work, then we would have to switch them around and go the 1 and the 6 here and the 2 and the 3 here. But again, I'm anticipating that my number needs to be relatively large, so I'm going to start with the larger numbers to the right here. So if I test my outer and inner product here, I get -30x plus 1x. That's not going to be the case, so I can eliminate my first set. What about my next set? -15x plus 2x. Does that give me the middle, the sum that I'm looking for? Yeah. So you have your answer right here, and it was the second trial. So it is pretty efficient. We went through it quickly. If that's the case, look to use that method. Okay, now, if you're unsure of that, or you prefer using the rewrite the middle term, we can do that as well. 5 times a -6 is -30. What two factors of -30 have a total sum of -13? -15 and a +2. Okay. So when you look at these, you can rewrite the middle term as that sum, drop your first and last term down, and then factor by grouping. So what common factor can we remove from the first pair of terms? 5x, leaving an x minus 3. And what common factor can we remove from the second pair? 2, leaving x minus 3. If we've done it correctly, we have a common factor, a common binomial factor, x minus 3. And then the remaining factors, 5x and 2, form the terms of our other factor. So again, that's still the rewriting the middle term is still a pretty efficient way because you're not wasting any work. And so again, I don't care which method you choose. All right, B. B is a similar type of problem. It's slightly different, okay, but it's set up the same way. Our leading coefficient is prime, so that means there's only one potential combination for that, 5x and x again. But now our last term is a +6. Now the y's carry with it, so we'll use that as well. But since our product, or the last term is a positive, that means when we take the product of our last terms, they have to have the same sign, right? A product to be positive needs the same signs. So since our middle term is negative, what is that sign going to be, positive or negative? We know it's going to be a minus, right? And so now we have this same set of combinations here. that we had to start with. Okay, only this time the signs are the same. So as we test it, 1 and 6, 2 and 3, 3 and 2, 6 and 1. Okay, so looking at these different combinations here, okay, we can test and see which one works. We only need to test 4 possibilities, so let's go through. So if we take our outer plus our inner product, okay, so outer is negative 30 minus 1. That's not going to work. Negative 15 minus 2, does that work? No. What about negative 10 minus 3? Yeah, that one works. So here are your factors, and you get your answer, 5x minus, and we have to carry along the y for these. So 5x minus 3y and x minus 2y in order to get that last term to be 6y squared. Okay, now, once again, if we were choosing to use the rewrite the middle term method, we would take 5 times 6, which is 30. Now, what two factors of positive 30 have a sum of negative 13? Negative 10 and negative 3. So if we rewrite our middle term as the sum of those, drop our first and last terms down, and then factor by grouping, what common factor can we remove from our first pair? 5x, leaving a x minus 2y. And from our second pair, negative 3y, leaving an x minus 2y. We have our repeated binomial factor. Remove that. And then the remaining factors, 5x and negative 3y, form the terms of our second binomial factor.
After you break down the number, like when you have just the 30 and
Yep.
the 10xy or negative 10xy, does it matter what side you put those on?
No, it could be, if you put negative 3xy minus 10xy, you're still going to get the same answer. Okay? So let's take a look at that. So if we had written negative 3xy minus 10xy, and you tried to drop the first and last terms down, okay, when we look to remove our common factors, what can we remove from this first pair of terms? Just an x. We're left with a 5x minus 3y. And from the second pair of terms, what can we remove? 2y, leaving a 5x minus 3y. So now our repeated binomial factor is the 5x minus 3y, and our remaining factors form the terms of our second binomial factor. Right? And it doesn't matter which order you write them either online. They're both binomials. They should it should accept it either way. All right, let's go through C. Okay. How many people tried the rewrite the middle term for C? Okay, now, I want you to look back at it more closely. What should we start with for C? What's always the first step of factoring? Remove a common factor, right? Are there any common factors between these three terms? Yeah. Take out a 3, right? If you take out a 3, you get x squared minus 4x minus 5. And now, when you simplify, reverse foiling is the ideal method because your first terms have to be x. What two factors of negative 5 have a sum of negative 4? Minus 5 and a positive 1. And now, if you had done this by rewriting the middle term, you're still going to get your same answer. Now, you'll either get 3x minus 15 times x plus 1, or you're going to get x minus 5 times 3x plus 3. Okay? If you have either of those forms, you're not completely factored yet. You would have to remove that common factor of 3 from them. Okay? So, again, if you can factor it out early, it simplifies the problem for you, and it eliminates the opportunity to make that little common mistake. Okay, so look for that first. All right, for D, okay, what do you notice about the first and last terms on D? Are they both perfect squares? 9y squared is the quantity, 3y squared. What about the last term? The 4 is a perfect square, but what about the fact that it's a negative 4? So that's not a perfect square. So it doesn't fit the perfect square trinomial form here. And so what you're going to do is you will either use trial and error, or you'll rewrite the middle term. Now, neither 9 nor 4 is a prime number. So my suggestion right then would be it's probably just sufficient to expand it out, rewrite the middle term. Okay, so if we take 9 times a negative 4, we get negative 36. Are there factors of negative 36 whose sum is positive 9? Okay, so you have positive 12 and a negative 3. Okay, so I'm going to rewrite my middle term. Notice I put my positive term second. It's not a requirement, but often it, again, makes it just a little bit less likely to make a careless mistake in factoring out a negative. Okay, so what common factor can I remove from my first pair of terms here? 3y leaving a 3y minus 1. What common factor can I remove from my second pair of terms? 4 leaving a 3y minus 1. I have my repeated binomial factor. I'm going to factor that out. And then the remaining factors, 3y and positive 4, form the terms of my last binomial factor. All right, the final example here. Again, look to see, can you remove any common factors? No. Okay, so let's try our rewriting the middle term. Again, neither the leading coefficient nor the constant is a prime number. So 12 times 6 gives me 72. Are there two factors of 72 whose sum is 17? The answer is 8 and 9. So if I rewrite my middle term as 8x plus 9x, drop down the first and last terms, and factor by grouping, what common factor can I remove from my first pair of terms? 4x, leaving a 3x plus 2. What common factor can I remove from my second pair? 3, leaving a 3x plus 2. I have my repeated binomial factor. That comes out. And then the remaining factors, 4x and 3, form the terms of my second binomial factor. All right. Questions on that? Is it getting a little more comfortable working with it? And now, here's my warning about this. Just like with everything else, I've warned you about, like, giving you this exact same warning before, which is when you guys learn something new, you tend to apply it to everything and not just what it applies to. So a lot of people take this kind of factor, like x squared minus 4x minus 5. If I ask you to factor that, a lot of students, after I go through this method, will take 1 times negative 5, which is negative 5. What two factors of negative 5 have a sum of negative 4? Negative 5 and positive 1, right? So a lot of people will do this for every problem. Now, are you going to be wrong if you do it this way? No, it's still going to give you the right answer. But is it as easy as just taking what two factors of negative 5 have a sum of negative 4? It's not as easy as that. Okay, so even though you can use rewriting the middle term for every single type of problem, including the binomial square or perfect square trinomial type, in my opinion, if you can use the other patterns, do it. Save this only if your leading coefficient is something other than 1 and it doesn't fit the perfect square trinomial form.